Hi everyone, this is the video presentation for the micronutrient projects over folate, and today I will review the role of folate and folic acid in cancer. So I want to start things off by explaining a little bit of the metabolic role of folate. We have learned in class that folate is part of many metabolic processes, but those that are important for this presentation are DNA synthesis and DNA methylation. As we know, folic acid is a synthetic form of folate, which is commonly found in 45 products and supplements, and is actually more bioavailable than folate. Folic acid and folate are actually metabolized differently in the body upon entry, as we can see in this figure. Folic acid is converted into dihydrofolate first, while folate is converted into 5-methyl tetrahydrofolate first. And this will be important later in this presentation. But in the end, both of them can help to produce SAM, as we can see in the left part of the figure, which is needed for DNA methylation. To avoid repeating what we have learned in class, I will only mention that inadequate production of SAM may affect expression of tumor suppressor genes and proto-oncogenes, which is the reason this is important in relation with cancer. Folate also helps to produce deoxyurine monophosphate, or DUMP, as we can see in the right, which is necessary for DNA synthesis and repair. For that reason, a high intake of folate can be associated with the protection of multiple different types of cancer, especially in the context of high alcohol consumption and compared to low folate intake. Now I will explain a little bit more of the risk of high folate intake. The fact that folate has a central role in DNA synthesis and DNA expression could also mean that a high availability could lead to the proliferation of rapidly dividing cells, especially precancerous and cancerous cells. That is the reason why folate inhibitor drugs are actually used for cancer therapy. Additionally, it's not uncommon for precancerous and cancerous tumors to remain undetected due to a lack of initial signs and symptoms, sometimes for even more than 10 years. But of course, this depends on the type of cancer we are talking about. It has also been reported that folic acid above 400 micrograms may saturate the dihydrofolate reductase enzyme, which, as I explained in the last slide, folic acid is converted by this enzyme to dihydrofolate upon entering the body, and that's the reason this is important. And this situation leads to a high level of unprocessed folic acid in the blood, which has been hypothesized as a potential mechanism for carcinogenesis. However, more research is needed to understand this, since no major studies have proven this hypothesis. In fact, one of the biggest cohort studies in the US, with over 500,000 participants over an 8-year period, found an inverse association between dietary folate and risk of colorectal cancer in both the pre- and post-fortification periods, especially for those using a multivitamin supplement. Here we can see the NHANES report for 2017 and 2018 about folate intakes for males and females in different age groups. This is an excellent table. It shows a lot of information, but it could be a little bit hard to understand. So I want you to focus your attention to the section in the left that says gender and age, and I want you to find where it says all individuals, right in the bottom. There we can see that around 22% of the population aged 2 or more uses supplements. And if we keep reading that same row, we can see that the average intake for those taking supplements is 1237 micrograms, including food. And this is above the upper tolerable intake level for folate, which is 1000 micrograms. Based on what I mentioned in the previous slide, high intake of folate might present a risk for those who currently have or are at risk of developing any form of cancer, such as older adults, especially when this is in form of unmetabolized folic acid due to supplements. The enhanced data also shows that around 35% of adults aged 60 or more consume a folate supplement, and they actually have a slightly average folate intake compared to the 1237 micrograms of the general population, which is a little bit concerning since they are at risk of developing cancer more than other age groups in the population. We can also see here that those that don't take folate, if we look all to the right, have an average folate intake above the recommended daily amount, which is 400 micrograms, which is perfect. Means that the fortification is working. Now I will talk about research linking folate and breast cancer, which is the most common type of cancer among women. It has been, it has been found that cancer cells have a high expression of folate receptors, which may promote the growth of tumors. We have learned in class that folate is transported into the cell through folate carriers. However, folate receptors also help in this function too. The main difference between both of them is that folate carriers have a higher affinity for naturally occurring folate, while folate receptors, such as folate receptor alpha, have a higher affinity for folic acid. And, and to further support the carcinogenic role of folate receptors, when folate receptor alpha is inactivated in human breast cancer in vitro, it resulted in a decreased survival and size of tumor cells. Additionally, it was found that in the large tumors, the STAT3 oncogene was activated, which increased cell proliferation, angiogenesis, and inhibition of apoptosis. And this happened after folic acid treatment. So, continuing with the with breast cancer, a animal model found that folic acid promoted the growth of tumors due to the abnormally high expression of folate receptors in cancer cells, which also normally occurs in many different human cancers such as colon cancer, breast cancer, and ovarian cancer. Mice receiving a high folic acid diet show a 1.9-fold increase in the total tumor volume, and the number of tumors above 100 cubic millimeters were increased by 1.9 times as well. The number of tumors above 200 millimeters cubic millimeters were increased by 11 times after uh, folic acid treatment. And it was concluded that the expression of folate receptors, especially folate receptor alpha, positively correlated with the severity of the tumor. Now I will talk about the research linking folate and prostate cancer, which is the most common cancer type among men. A randomized study including 643 men found out that the folic acid group with an intake of 1,000 micrograms had a prevalence of 9.7% of prostate cancer, while the placebo group had only a 3.3% over a 10-year period. Even though the results of this study were determined from 1996 to 2006, it's still the main reason why the National Cancer Institute recommends avoiding high intake of folic acid. In the National Cancer Institute website, the consumption of folic acid is listed as a risk factor for prostate cancer, while folate consumption is listed as a protective factor. More recent studies have found similar results where high blood folate levels were associated with a higher risk of prostate cancer, which also supports what I mentioned earlier in this presentation about the risk of unmetabolized folic acid in the blood. Another potential mechanism by which unmetabolized folic acid could increase the risk of prostate cancer is by reducing the ability of natural killer cells to work properly. And this is part of a prostate-specific antigen with folate activity, which tend to be overexpressed in nearly all patients with prostate cancer. However, the evidence still mixed, since other studies have found that dietary and total folate intake, that means with after supplement intake, was not associated with a higher risk of prostate cancer, at least in a 5-year period. Uh, but more research is needed to clarify the role of folate and folic acid in prostate cancer. So I want to finish this presentation uh, based on what I mentioned about the risk of folic acid in cancer. I want to answer the question of whether we should change supplementation and fortification practices in the US. I want to start things off by mentioning that the mandatory fortification of folic acid in the US and other countries, such as Peru, has helped to reduce the prevalence of neural tube defects and help the population, especially pregnant women, to meet their folate requirements. And if you want to go back to the, if you want to go back to this presentation video, you can see that this is evidenced by the enhanced report that I showed at the beginning of the presentation. On the other side, high folic acid intake might be a risk factor for a large section of the population, such as older adults, since age is associated with a higher risk of developing cancer. However, it's not appropriate to make any definitive conclusions now about the impact of folic acid in the development of some types of cancer because the results in the literature are still mixed. Further research is needed to evaluate this change. Further research is needed to evaluate and change the current fortification practices and the amount of folic acid found in multivitamins. It may be valuable to evaluate the metabolic impact of using other folate compounds instead of folic acid for supplementation and fortification in case the situation occurs, especially since we have seen before uh, folic acid and folate are actually metabolized different upon entering the body, so it's likely that other folate compounds might do the same. It is also important to consider that folate or folic acid work together with other nutrients and compounds in metabolic processes such as DNA synthesis and methylation. By studying the folate or folic acid intake or serum levels in isolation, we may be missing the critical role of synergy among nutrients and other compounds. Before I finish, I want to make clear that consumption of dietary folate is unlikely to be high enough to reach upper tolerable intake levels. Additionally, natural sources of folate can also give other nutrients and compounds that can contribute to health, so please consume folate. So to answer back the question of whether we should change supplementation and fortification practices, my answer is that not yet until more research shows otherwise. And these are my references. Thank you.